Good morning students, welcome to the GPREC Center for Digital Education of E-Content Development Program on the module Concrete Technology subject. In today's lecture video, we are going to discuss a topic in concrete technology, that is lecture number 4, aggregates. So before entering into the aggregates concept, let us introduce myself. I am M. Hemant Kumar, working as an assistant professor in Civil Engineering Department from G. Pullareddy Engineering College, Autonomous, Kurnool. And coming to the aggregates topics, there have been divided in some of the topics. It is mentioned in this index part. So those topics will be discussed in this lecture video. Number 1, introduction of aggregates. So here we will be discuss what is meant by an aggregate, what is the purpose of an aggregate, okay, what are the importance of an aggregate. Next, how many types of aggregates and what are the classifications of its aggregates. So types are different, classification is different. Okay, done. Next, third one, properties of aggregate. So this is the properties of aggregate is very most important. So if the aggregates are available very natural sources, okay, wherever it is available, we should not collect that material and directly we should not use for the concrete mixture. So we have to check the properties. So those properties we will be discuss in this lecture video. And fourth one is what are the tests conducting on the aggregates, tests on aggregates. Okay, why we have to conduct? Nothing but to determine, okay, nothing but to determine the what properties of aggregates are having. So we have to conduct the test. And last one is alkali aggregate reaction. Okay, now coming to the aggregates, what is mean by an aggregate? Okay, so in the previous past lectures, the title of a module is concrete technology. So nothing but we are going to be discussing on the subject concrete. So what is mean by concrete? We have to know first. Concrete is a mixture of cement plus, okay, sand plus coarse aggregates plus water. Okay, so in the past lecture videos, lecture 2.1 and lecture 2.2, we have discussed on cement. Okay, and coming to the lecture 3.1 and lecture 3.2, we have discussed an admixtures. Admixtures are, it is an additive material agents will be mixed during or before the mixing process of a concrete member. Okay, now in this today's lecture video, we are going to be aggregates. Where the aggregates are going to be using here? See, in the concrete, cement will play an important role. What is the type of a role? Nothing but this cement, it provides binding nature. Okay. Okay. Then how the binding nature will be how? When this cement will have when the water is mixed with the cement, a reactions will be developed. So due to that reactions, the binding property will provide. Okay, done. Now coming to the concrete member. What are means by concrete member? Nothing but beam, column, next slabs, footings, etc. Whatever it may be, any structural member, it will be constructed with the concrete member. Okay, so in that concrete we will be add first one is cement. Purpose of a cement, this one. Then where is the aggregate? What is the purpose of an aggregate? So you people can observe here, one of a image is presented. These are the different types of aggregates. Okay, now what is mean by an aggregate? Aggregate is also one of a basic and natural resource material. It provides in concrete to improve the strongest bond for a concrete member. See here, cement is there. Cement will be provide to improve the binding nature. Then where the strongest nature will become from the aggregates. So those aggregates we are going to be discussing. So the aggregates are divided in two types. One is a fine aggregate, another one is a coarse aggregate. Where in this image, where is the fine aggregate? This is the particles are having very fine particles. This is fine aggregates. How we can define? If the aggregate is more than or less than 4.75 mm, then we are going to be defining as the type of the classification of size of aggregate will be having two types. One is a fine aggregate, which the size of a sand is having less than 4.75 mm. Then what is the coarse aggregate size? Nothing but it is more than 4.75 mm. This is coarse aggregate. So these are the coarse aggregate particles. See here, all the size particles are having more than 4.75 mm. So the strongest bonding nature, it will be provided by the coarse aggregates. Then what is the purpose of a sand? Okay, what is the purpose of a sand? Sand also, it provides reduce the air voids. So the aggregates are nothing but which provides the strongest nature and reduce the air voids in a concrete member. So sand plus coarse aggregates are the aggregates. Okay, now we have got the concept to know. Done. Now we will come to the definition part. Okay, see, and aggregates are granular materials such as available in the rivers, seas and any desert areas. But for the construction point of view, most of the things we will be use the river sand. Okay, so the river sand will have the standard and perfect size particles. And coming to these type of coarse aggregates, it will be available in the gravel as natural, or else any crushed materials from the manufacturing places, or else crushed materials from the factories. Okay, see, so aggregates are granular materials such as sand, gravel, crushed stone or crushed slag that form the major portion of 60 to 70% in concrete volume. Okay, for example, let us take a concrete member. So this is a beam, cross section of a beam. Okay, in this beam, cement particles will be there. Aggregates will be there. Nothing but coarse aggregates will be there. And water also will be there. Sorry. Oi. See, this is a water. This is a sand particles. And this is a coarse aggregates. See, next, this is a cement. Okay, this is a cement. Now you see, this is water, this is a sand, this is coarse aggregate, and this is cement. Okay, done. Now coming to this concrete member. So this is a cross section of a beam. In this cross section of a beam, what the materials, what the ingredients are presented? Nothing but water is there, sand is there, coarse aggregate is there, cement is there. So coming to the part the sand and coarse aggregates, it contains 60 to 75 percentage of volume, nothing but the quantity. For example, in 100 percentage, okay, in 100 percentage, if 60 percentage of aggregates are going to be present, then what is the remaining 40 percentage? Nothing but the 40 percentage is cement paste. Okay, so in the concrete member, if you are taking 75 percentage of aggregates, in that aggregates coarse plus sand will become, then remaining 25 percentage will be taken as cement and water. This is a very important question for your objective parts. Okay, so that is the concept. Aggregates are the available as a natural sources of materials. It will be available as a sand or any gravels or else any granular stones, and it will be form the major portion in a concrete member, 60 to 75%. Okay, done. What it provides in a concrete member? Okay, so these are the aggregates we are using. No, what is the purpose? Simple. To reduce the air voids, we are using sand. Okay, to improve the strongest nature, very strong. Okay, that strongest nature will be provided by the coarse aggregate. So if these two conditions are satisfied in a concrete member, then it will be provided as the strength of a concrete member, the stiffness of a concrete member, and the dimensional stability to the concrete member. Okay, now you have understood now what is an aggregate. Aggregate is one of a basic and natural source material, resource material. Okay, it is adding in a mixing the process of concrete material, and it requires 60 to 75 percentage in a concrete volume. Okay, done. Coming to the types. The types of aggregates. The types of aggregates will have in two types. One is depends on the size. Okay, if the aggregate is having, the size of an aggregate is having less than 4.75 mm, then we are going to be calling as sand. If the aggregate size is having more than 4.75 mm, then it is going to be calling as coarse aggregate. Sorry. See, if the aggregate size is having less than 4.75 mm, then it is going to be calling as fine aggregate. If more than 4.75 mm, then it is going to be calling as coarse aggregate. So in this image, where is the less than where is the fine aggregate? Where are the coarse aggregates? So this is fine aggregate, and these are the coarse aggregates. How we are going to be defining? So the fine aggregate size is less than 4.75 mm, and the coarse aggregate sizes are which is more than 4.75 mm. More than, nothing but 4.75 mm, next to 10 mm, 12 mm, next to 20 mm, next to 40 mm, next to 60 mm, 50 mm, 60 mm, 40, 80 mm, like that it will be available. Coming to the fine aggregates, less than 4.75 means 4.75 mm, 2.36 mm, 1.18 mm, like that. Next to 600 microns, 300 microns, 150 microns, 75 microns. So these are the different size particles will be done by the sieve analysis. Okay, done. So these types of aggregates will be discussed according to the classifications. Okay, now we have understood now. So the fine aggregate, the size is going to be represented as less than 4.75. The coarse aggregate size is going to be represented as more than 4.75. Then what the names we have to be used? What is the terminology we have to be used? For fine aggregates, we will be used as sand. Next, for coarse aggregates, we are going to be using as gravel or crushed stone. okay, gravel or crushed stone. Okay, these topics we will be discussed. All the particles are having same size, same shape, same surface texture, or same sources are available? No, in different. So for that purpose, how we have to be select, how we have to be classify, we will be move into the next slides. Okay, done. Now classifications of aggregates. So the classifications of aggregates will have in different forms. One is according to the size, second one is according to the shape, third one is according to the source, fourth one according to the surface texture. Okay, so one is size, shape, source, surface texture, and last fifth one is according to the weight. See, S power 4. S power 4 means one is the size, another one is the shape, next one is the source, next one is the surface texture. Okay, see here. In a small image I have mentioned here, the classification of aggregates will depends on the size and shape matters. So, and also the lightweight. So the weight will become lightweight aggregates, normal weight aggregates, and heavyweight aggregates. Okay, done. Next. Coming to the types of aggregates. So the types of aggregates are how many types? Two types. One is fine aggregate, another one is coarse aggregate. Okay, how these two, fine aggregate and coarse aggregates, are going to be separating due to the classifications. What type of a classification? These two will become under classification based on size. Based on size. So the types of aggregates are depends on the classification of aggregates. Now we will see what classification. Based on size, the type of aggregate is going to be dividing. Second one, classification based on sources, natural source, or else manufacturing source, or else recycled sources. Next, third one, based on shape. What type of a shape? Whether the aggregates are available in shape. Then what are the types of shapes? Rounded aggregates, angular aggregates, flaky aggregates, or irregular or elongated aggregates. And fourth one is according to the density, nothing but weight. So nothing but lightweight aggregates, normal weight aggregates, and heavyweight aggregates. And last fifth one is nothing but classification based on surface texture. Okay, again in the classification based on surface texture, the types of aggregates are going to be divided in two categories. One category is rough surface texture, next one is smooth surface texture. Okay, see, these are the 5 classifications. Okay, these are the 5 classifications that we have discussed here also. Okay, done. See, now we will see each type of aggregates depends based on the classifications we will be discussed. Now, the type of aggregate is going to be divided according to the classification of based on size. So there are having two types of sizes. One is less than 4.75 mm, another more than 4.75 mm. So this less than 4.75 mm is going to be calling as fine aggregates. Okay, if the coarse aggregates are having more than 4.75 mm, that is going to be calling as coarse aggregates. Done. What is the examples of fine aggregates? Nothing but river sand or manufacturing sand. Nothing but the sand will be used for the plastering purpose also, for the finishing purpose also, and also to reduce the air voids in the concrete member also. Next, coming to the coarse aggregate, the particle size of a coarse aggregate is nothing but more than 4.75 mm. You people can observe here. See, here all the particle sizes are more than 4.75 mm is presented. See, the size less than 4.75 mm. This is a sand particle and this is a coarse aggregate particle. Here gravel will be present, cobbles will be present, pebbles will be present, all the different sizes will be present. Okay, next. Done. So that is one of a type of aggregate based on the classification of size. The second type of aggregate based on the classification of sources. Sources means availability criteria. So where the aggregates are going to be available? In river. Okay. Next, seas or oceans. There also sand will be available. Next, desert areas. So in rivers sand is available, in rivers sand is available, that is fine aggregate. In seas and oceans fine aggregates also available, that is sand. Next, in the nothing but desert areas, there also fine aggregates will be available, nothing but calling as a sand. But for the construction purpose, which sand we have to be used? So for entire construction process, we have to be use the river sand. River sand is most important and more applicable for the construction purpose. Why? Because this river sand is free from any minerals and free from any contaminants. And also the size particles of the river sand will have as a standard particles. Coming to the sea and desert sands. In sea sand, it is containing salt contaminants. Salt contaminants. So those sodium, it will be effective for the building construction and building members. Okay. Next, desert sand. Desert sand is good, but it is having very less size. So very fine particles will be providing in desert sand. So for those desert sand, it can't be used for the construction purpose. Why? Because it is having very less weight. Okay, just if we take in our hand, just you blow like this, so it will be go away. Okay, so for the construction purpose, whatever it may be, so the river sand is taken. Again, from this sand, there are having three types. One is coarse sand, another one is a fine sand, coarse sand, medium sand, and a fine sand. Okay, done. So the classification based on the sources, there are having three sources. One is available as a natural aggregates. Second one, manufactured aggregates. Third one, recycled aggregates. See, natural aggregates means where the aggregates will be available in the natural areas, nothing but rivers, nothing but the river sands. Next, gravels. Okay, next, the availability of aggregates in manufacturing places, factories. So nothing but examples are crushed stone or manufactured sand. For example, sir, near our city, near our town, there is no rivers, but the sea and ocean is there. Can we use that sand? No. Why? Because in sea, the availability of a fine aggregate, it provides the salt contaminants. That salt contaminant is not useful, is not good for the construction purpose. Okay, done. Now coming to the how, sir, we have to be use that, how, sir, we have to be avail that fine aggregates if the sea is not there, if the rivers are not there. Simple. Just you go far away from your place, all the rock particles will be available. Those rock particles just carry or transport from that place to manufacturing places. So whatever you want the size, if you want 40 mm size, or else if you want 20 mm size, if you want 12 mm size, if you want 10 mm size, if you want 4.75 mm size, so those crushed, so those rock materials will be converted as a crushed stone materials. So those are the artificial aggregates, nothing but manufactured aggregates. Okay, done. Next, resiled aggregates. So this is a very easy form. So nearby the construction areas, any demolition is there, so the demolished particles just you collect and get to the factory and do the crushing process. So all the crushing materials, demolished materials will be crushed and it finally gives the demolished aggregates. These are the recycled aggregates. Okay, next, the type of a aggregate is classified based on the shape. So all the aggregates are having same shape. What are the shapes? Square or rectangular or circular or triangular. Which shape? So not these types of the shapes. So the shapes will be defined as rounded shapes, angular shapes and irregular shapes. For the construction purpose, which type of which shape of aggregate should be used? Nothing but angular shapes. Okay, now coming to the based on shapes, the rounded shapes where the pebbles will be available as a rounded shapes. Okay, next, angulars means where the surface of a aggregate will have more angles. Different angles will be providing in that aggregates. So those angular aggregates should be used for the construction purpose. Why? Because after filling that concrete in a specific location, we will do the compaction. Due to that compaction, the vibration will be happen. All the angular aggregates will have fitted in those angles from one each other. From one aggregate to another aggregate, it will be filled like this. So that's why the angular aggregates are very good. Coming to the irregulars, it will be having two types of shapes. One is flaky, another one is the elongated. Flakiness, it indicates thickness part. See, like this. Coming to the elongated, it indicates length of a aggregates. See how much length it is there, how much thickness is there. The thickness part, it will be considered as flakiness. Irregular shapes, okay, very less angles will be provided. Like this. This is the length. See, this is the length. Like this, it will be available. Next. Next, coming to the density. The density means which depended on the weight of a aggregates. It will be available in three types. One is lightweight aggregates, normal weight aggregates and heavy weight aggregates. So what are the lightweight aggregates are there? Nothing but pumice stone, expanded clay particles. Next, what are the normal aggregates is available? Nothing but crushed stone. For the any type of a construction, we will be use normal weight aggregates. Okay, normal weight aggregates. Coming to the heavyweight aggregates. Okay, coming to the heavyweight aggregates. Okay, see, heavyweight aggregates will be used for tall buildings or tall structures. Okay, and last one, the type of aggregate is going to be classified based on the surface texture. In this surface texture, there are having divided in two types. One is smooth surface, another one is the one is rough surface texture, another one is smooth surface texture. Okay, you just see the aggregate surface is having smooth surface or rough surface. See, so the aggregates will be available mostly in rough surface. What about the smooth surface? Pebbles, small stone particles which will be available in the sea areas, seas, samudram. Okay, so those are will be having smooth surface texture. But for the construction point of view, which surface texture is very most useful means rough surface texture. Why? Because due to the having the friction, very good bonding will be provided. Coming to the smooth surface texture, it won't be develop any friction. For easy rotation process, easily it get collapse or break down. Okay, so the surface texture is good as rough surface texture for the good construction purpose. Okay, next. And coming to the part for the aggregates, it is having the code books. Okay, as per IS, as per Indian standard IS 383/2016, we can refer the specifications of aggregates. Next, coming to the IS 2386 part 1, part 2, part 3, part 4, part 5, part 6, part 7, part 8. What are these parts? It will be includes the types of test conducting for aggregates. For example, sieve analysis test, size test, shape test, next strength test, next specific gravity test, these water absorption test, all the different types of test will be conducted in available in IS 2386 part 1 to part 8. And for the construction purpose, what type of a aggregate? Nothing but 20 mm size or 40 mm size. So for that one, which is the good grading process will be available. Whether it is good, poorly graded, uniform graded or well graded. Poorly graded also nothing but calling as gap graded. Okay, so those aggregates will be used in concrete purpose. Okay, next, zones, zone 1, zone 2, zone 3, zone 4, these are the conditions will be applicable in IS 456/2000. Okay, now coming to the properties, now came to the main important zone. The properties of aggregates greatly influence the strength, durability, impact, toughness, abrasion, nothing but wear and tear, water absorption, grading. Just now has said grading. It will be aggregates will be divided as 3 types of grades. Whether it is well graded or uniform graded or gap graded or poorly graded, depends on this condition. As per IS 456, we will select the grading of aggregates and good workability for the concrete. See, important note, a good aggregate should possess the following properties. What are those properties? Here I have mentioned. See, size and shape, surface texture, specific gravity, water absorption, strength test, Okay, next toughness, hardness, durability, gradings. These are the different properties can determine from the conducting test on aggregates. Okay, to determine size property, shape property, and surface texture property, what type of a test we can conduct? Nothing but sieve analysis test. Nothing but a sieve analysis test. So here set of sieves will be arranged. So these are the different types of laboratory work. I will be explained in the next lecture video. Okay, so sieve analysis size. Nothing but here set of sieves will be there. For coarse aggregate, the set of C's will be arranged as from starting onwards we will be discussed. So 80 mm, next 40 mm, for the 20 mm, next for 12.5 12 mm, next to 10 mm, 4.75 mm. Here it is enough. Finally a pan will be provided. Okay, again if you go less than the 4.75, then it will be kept as fine aggregates. So how the sieves will be arranged as 4.75 mm, 2.36 mm, 1.18 mm, 600 microns, 300 microns, 150 microns, 75 microns, finally pan. Okay, these are the set of sieves will be arranged for fine aggregates. So due to having this sieving during 10 to 15 minutes, we will get the different size particles of the aggregates will be retained on different sieves. Then we will get all the weight and we will calculate, we will do the grading curves. Okay, here we will get the shape of a aggregate, the size of a aggregate, and the surface texture of a aggregates. Okay, next it will be provides the importance. What it will provide, so what is the importance to determine the size and shape? Nothing but it will give strength and good workability. What is the surface texture? What is the importance of a surface texture to determine it? Nothing but good bonding strength. See, surface texture, rough surface texture, it provides a good bonding strength. Next, pycnometer property. It will be used the specific gravity property of aggregate. It will be used the pycnometer method, and that is density and strength. Okay, next water absorption strength, water absorption property, nothing but for the durability. Next crushing strength. So here we are going to be conducted as a strength test, nothing but crushing strength test. It will having the load resistance. Next, toughness of the aggregates, nothing but impact test will be conducted due to the impact load on a aggregate material. How much toughness property is going to be provided, nothing but the impact resistance importance. Next, abrasion, that is hardness, wear and tear resistance. Abrasion means due to the having two different materials or friction will be developing. Next, durability for the long life, and grading for the economy and good workability purpose. These are the aggregates. Okay, from these aggregates we will be discuss. Let us few. See, properties of aggregates. Here it is going to be defined as sizes, shapes, surface, specific gravity. Next, bulk density and porosity. See, you people just observe the image here. So here having one side is shape, another size is size. See, how many shapes are there? The property of shapes. There are having three types of shapes: rounded shapes, angular shapes, irregular shapes. See here, rounded shapes, angular shapes, these flakiness and elongated, it will become under irregular aggregates. Okay, these are the shapes. Coming to the size, 40 mm, 20 mm, 12 mm, 10 mm, 4.75 mm, less than 4.75 mm sand particles. See, all the aggregates particles are having same size or same shape and same surface nature? No. all are having different purpose. Okay, see. So first property is size of aggregates. It is available in two types of sizes. One is coarse size, another one is a fine size. The coarse size is having more than 4.75 mm. So the availability of aggregate in this image, it is more than 4.75 mm. So that is coarse aggregates. Okay, then what are the fine aggregates? Sand particles. Okay, next coming to the shapes of aggregates. See, if you observe here, all the shapes of the aggregates are having same, whether it is cubical, triangle. No, we should not say as a triangle. All the angular. See, here is there one angle, here is there one angle. Okay, here is there another angles, here also one angle, here and here. How many angles are presented? See, so that's why if the surface of a aggregates is providing more angles, surface angles, then it is going to be calling as angular aggregates. Coming to the irregulars, see, here angles will be present but less. See, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7. Everything you just observe here. But coming to the rounded shapes, whether it is providing angles, just to see like pebbles or rounded surface. But for the construction point of view, angular materials are very good. Then what about the irregulars? Irregulars are flakiness and elongated. See, what is the thickness? It is going to be provided. What is the length? That is elongation. So in irregular, it will become flakiness and elongated of aggregates. Okay, done. So for angular aggregates, it will provide high strength and less workability. Rounded, it will be provide the good workability, nothing but the river sand and gravel particles. Next, surface texture. See, all the stone particles, all the aggregate particles will having the same surface texture? No, rough surface texture. So rough surface texture, it provides better bonding with the cement paste. Smooth surface texture, less bonding, but it will have the good workability. But for the construction purpose, we will take rough surface texture. Next, specific gravity. Okay, specific gravity, it indicates density and strength. So the specific gravity will be conducted both for the two types of sizes. One is coarse aggregate size, another one is fine aggregate size. What is the range will be provided for the coarse aggregate? According to the IS 2386 code book, for coarse aggregate, the specific gravity is going to be providing as 2.6 to 2.8. Next, for the fine aggregates, the specific gravity is going to be provided as 2.5 to 3.0. Okay, next, bulk density. What is meant by a density? Mass by densities. Okay, density equals to mass by volume. It affects concrete mix proportioning. Next, porosity. Next, porosity and water absorption. So the porosity and water absorption is high porous nature. It will be provide high water absorption. Porous nature means nothing but all the air voids will be provided in the aggregate parts. Nothing but porous stone. And pumice stone will be tell no. So those aggregates will have porous nature. So those porous nature of aggregates, it will absorb the water heavy. Okay, so it should not be good there. So the water absorption should be generally done as 2%. If all the aggregates you collect and dip in your water up to 24 hours, and you just take those aggregates, wet aggregates from the water after the 24 hours and just get the weight and do the calculation part. Okay, there will be having a weight variation. Then you just cross check. So the result, it should be get less than 2%. Okay, done. So if, for example, if you are taking 100 grams of aggregates, after dipping after dipping into the water up to 1 day, nothing but 24 hours, it will increase the size. So for example 120 grams. Then you calculate wet minus dry, nothing but 120 minus 100 by 100, 20 by 100 into 100, so 20 percentage. See here how it much, nothing but 20 percentage is increased. So nothing but the aggregates are having porous nature, it absorbed the water 20 percentage, like that. Okay, for example 101, see, for example 102, like that. Okay, done. 101 by 100 into 100, so not 101. Okay, done. It's having small calculation part will be there, it will be located in that code books. Okay, so these are the properties of aggregates. So thank you students for having a small session of concrete technology subject. Thank you.